In this video, we'll be learning how to both multiply and divide fractions. So of all of the math operations we can do, add, subtract, multiply, divide, I actually think that multiplying is the easiest one to do on fractions. So when we multiply fractions, all we need to do is multiply the numerators or the tops of the fractions together, multiply the denominators or the bottom of the fractions together, and then simplify that fraction if possible. And what is really, really nice about multiplying fractions is that there is no common denominator needed. So unlike adding and subtracting fractions where we have to get a common denominator, with multiplying fractions, that's not needed. We don't need a common denominator. We simply multiply across the top, multiply across the bottom, and simplify. So I've got a couple examples here for us to look at in order to showcase that process. So here, if we look at the first example, we'll notice we have 2/5 times -3/10. Now, if you're concerned about the negative, what I think is easiest to do is to look at the fact that we have a positive number times a negative number. And we know that a positive times a negative is going to be a negative. So if that's easier for you, that's kind of my suggestion, is to start by looking at, oh, we have a positive times a negative. We are going to have a negative result. Then from here, we can focus on the numbers. So here we can do 2 times 3, which is multiplying the numerators together, which is 6. And then we have 5 times 10, which is multiplying the denominators together, which is 50. So we just multiply it across the top, multiply it across the bottom. Because it's a positive times a negative fraction, we know the result is a negative. And then from here, all we have to do is simplify. And I know that these are both divisible by 2. So if we take the 6 and divide it by 2 in the top, that's going to result in 3. The bottom, we divide by 2 as well, that's 25. And then the negative carries over. So there is my final result. Now let's take a look at part B. So here, first I notice that we have a negative times a negative. And when we have a negative times a negative, we know that our result is going to be positive. So just kind of keep that in mind as we work. Then from here, you might be thinking, well, we don't have a fraction for this second number, but we can actually turn it into one. So here I'm going to take the fact that we have -2/7, and I'm going to rewrite this as a -3/1, because 3/1 is the same thing as 3. So if we don't have a fraction because it's an integer, we can turn it into a fraction by putting it over 1. Then from here, we simply multiply across the top again. So again, remember, a negative times a negative is a positive result, so we know our answer is going to be positive. Then we take 2 times 3, which is 6, 7 times 1, which is 7, and our final result is 6/7. Finally, in part C, we're going to take a look at the fact that we have 2 mixed numbers. And again, you might be thinking, well, what am I supposed to do if I have mixed numbers? How on earth do I actually turn this into a fraction that I can do math on? And my advice to you is, if you see mixed numbers, turn these into improper fractions to start. So remember, we can turn this into an improper fraction by taking 2 times 5, which is 10, adding the 1 on the top, which is 11. So we have 11/5. And now we're taking 11/5 times, here we have 3 times 3, which is 9, plus 1, which is 10. So we have a -10/3. So once we've turned these into improper fractions, then from here, the process is actually quite simple. Again, we note that we have a positive times a negative. We can see that in our work here. I'll highlight that in a different colors. We have a positive number right here times a negative number right here. Positive times a negative is going to result in a negative solution. And then we multiply across the top, which is 11 times 10, which is 110. And we multiply across the bottom, 5 times 3, which is 15. So our final answer is a -110/15. Now, before we move on and start dividing fractions, I just want to highlight the similarities and differences between adding and multiplying fractions, because typically once people learn both of these, adding and multiplying, they also start to make mistakes and interchange some of the steps. So let's say, for example, we have 2/3 plus 1/4, and then we have 2/3 times 1/4, and just kind of talk through the differences in processes. So the first main difference between adding fractions and multiplying fractions is that adding fractions requires a common denominator. So if we don't have a common denominator to start, we do need a common denominator when we add. When we are multiplying, though, there is no common denominator needed. So you can kind of note that first big change. So in the adding process, we're going to have to start by getting a common denominator, which in this case would be 12. So this would become, we would multiply this by 4, and we would get 8/12, plus we'd multiply this by 3, and we would get 3/12. So that would be our first step in adding fractions. But in multiplying fractions, we don't need that common denominator, so we don't need to take that step. Then from here, when we are adding fractions together, what we do is we simply add the numerators and leave the denominator alone. We don't change it. They stay in twelfths. So in the case of this problem, we will add the numerators across the top, so we'll get 11 over, leaving the denominator alone, 12. However, when we are multiplying fractions, this is where we multiply the numerator. We then multiply the denominator, and then after that we'll simplify, but we'll get to that in a second. So here we would multiply across the top, which would be 2 times 1 is 2, multiply across the bottom, which is 3 times 4 is 12. And so we can see that we actually end up with a result of 12ths at the very end in these two problems, but we can see that the answer is different. When we add, it's 11/12. When we multiply, it is 2/12. Then from here, our final step for each process, regardless of what we do, is we're always going to simplify that fraction. Now, in the adding fractions example I have here, that's not necessary, but over here in the multiplying one, we can see that that is something we can do. So 2/12, if we divide both by 2, this is going to become 1/6. So there you can kind of see the differences and similarities between adding and multiplying fractions. So before we start dividing fractions, I just want to talk about division in general and how division can always be changed to multiplication, because we're going to leverage that idea in order to make dividing fractions significantly easier. So hopefully at this point, some common knowledge you have is that 10 divided by 2 is equal to 5. However, there's also a number that we could multiply 10 by in order to get this same result of 5. So while yes, 10 divided by 2 is 5, the other thing we could do is we could take 10 times 1/2, and if we take 10 times 1/2, that is also equal to 5. And hopefully you're noticing that 2 and 1/2 are similar numbers, right? 2 is really 2/1, and then you have 1/2 down here, which is 1/2, and if you look, these are what are called reciprocals of each other. So we can change division into a multiplication problem by using this idea of a reciprocal and multiplying by the reciprocal instead. And so that's what we're going to do as we start dividing fractions. So when we're dividing fractions, what we're going to do is we're always going to start by rewriting that problem into multiplication problem by instead multiplying by what is called the reciprocal, which is meaning that we're going to flip that fraction around. And I like to call this keep, switch, flip, because essentially what we're going to do is we're going to keep the first number and not change it at all. we're going to switch it to a multiplication problem instead. And then we're going to flip the second number to its reciprocal. And if we do that, we can essentially take anything that is division and we can turn it into multiplication. And then because multiplying fractions is a pretty simple process, then from there, dividing fractions doesn't seem quite so scary. So let's just try a couple of examples here to see how this process works in action. So here we can see we have 3/5 divided by 8/5. And as I said before, we're going to take these division problems and turn them into multiplication. So we're going to use keep, switch, flip in order to turn every division problem into a multiplication problem. So keep, switch, flip means keep the first numbers. We're going to leave that just as is. We're going to switch it from division into multiplication. And then we're going to flip this fraction, the second fraction, to its reciprocal. So we have 5/8. So notice that we can take any division problem and turn it into multiplication by using keep, switch, flip. And now all we have to do is multiply these two fractions together. So we multiply across the top, which is 15. We multiply across the bottom, which is 40, and then we need to simplify this fraction by looking for common factors. So just by looking at these, I know that they're both divisible by 5. So if I divide both of these fractions, 15 divided by 5 is 3, 40 divided by 5 is 8, and there's my final answer. Now let's take a look at part B. And I know this one might look a little confusing having this big fraction here. So what I like to do is I like to rewrite this right off the bat. And so in order to rewrite this, the number that's in the numerator, that top number, is going to come first. So this is really -6 divided by 3/11. And so if you don't like the big fraction look here, just rewrite it with the number in the top or the numerator first, divided by the number in the denominator. Then from here, we're going to turn this into a multiplication problem by using keep, switch, flip. So we're going to keep that first number, which is -6, switch division to multiplication, and then we're going to flip this second fraction into its reciprocal. So this is going to become 11/3. Now remember, if we are dividing or multiplying with fractions, we can turn any number into a fraction to work with it. So what I'm going to do is I'm going to put -6/1 to turn that into a fraction, and then all I need to do here is multiply across the top and then multiply across the bottom since I've turned this into multiplication. So -6 times 11 is -66 over 1 times 3, which is 3. And for this one, believe it or not, this one's actually going to simplify really nicely. These are all divisible by 3. -66 divided by 3 is -22. 3 divided by 3 is 1. And so our answer here is actually a nice integer number of -22. Now, if you're wondering how I knew this problem was negative, remember we can kind of make that judgment call right off the bat by seeing we have a negative times a positive here, and a negative times a positive is always a negative. All right, final example down below, we can see we have some mixed numbers. Before we can start doing any math on this, we need to turn all of these mixed numbers into improper fractions because currently written as is, they're kind of hard to work with. So we're going to start by taking 3 times 2, which is 6, and adding 1 onto it. So here I know this is a -7/2. And then I have 2 times 4, which is 8, plus the 3. So this is -11/4. So here the problem I really have is -7/2 divided by -11/4. And then I'm going to take this division problem and turn it into a multiplication problem by using keep, switch, flip. So we're going to keep the first fraction, switch the division to multiplication, and then we're going to flip that second fraction to be -4/11. Then from here, I notice that I have a negative times a negative, so I know my result is going to be positive. And then we simply multiply the two numbers in the numerator and multiply the two numbers in the denominator. So we have 4 times 7 is 28. 2 times 11 is 22. And then from here, these are each divisible by 2. So we're going to divide each by 2, and we get a final result of 14 over 11.